All right, so we're now moving on to our last section of our last unit of the year, and that is solving basic exponential equations. After this, there are a few more topics that we're still going to learn, but they're no longer going to be part of our assessment or your power school. It's just getting you more prepared for next year. And what your goals for this video with basic exponential equations is you're going to know how to solve basic exponential equations. And one of the methods that you're going to have to learn how to do is you're going to have to learn how to manipulate your bases to solve some of these exponential equations. So we're going to start out in just the most basic form, and then we're going to get just a little bit harder where you will have to manipulate your bases on some of them. And it will also tie into what we learn with our laws of exponents when we're manipulating these bases a little bit as well. All right, so this is what your goals are for the end of this video, to know how to solve just basic exponential equations, and then we're going to take it just a little bit step further by having to manipulate some of our bases in order to help us to solve. All right, so first, before we start getting into solving any exponential equations, first we need to know, well, what is an exponential equation? And an exponential equation is where the exponent or part of the exponent, meaning that we can rewrite it as x plus 2, is a variable. So it's where our variable is in the exponent. So when we see a problem like this one here, you may think that this is an exponential equation because you see that you have a power of 2, but since our variable is our base and not in our power, this is not an exponential equation. Right, and this one we will actually solve a lot easier than what we're actually doing now. And this one, maybe you can identify, well, what raised to the second power is equal to 4? Well, we learned in our last video, or a couple videos ago, that our exponents and our roots are inverse operations of each other. So if I have something being raised to the second power, I can just solve this by taking the square root of each side. Because I know that when my power and my index match, that they're going to cancel each other out, and now I'm just left with x. And then the square root of 4 is equal to 2. And something we're actually going to learn in the near future is this actually generates two answers, a plus or a minus 2. Don't worry about that right now, but that is something that we are going to learn in the near future. So this one is not an exponential equation because our power is not a variable. And we could just take the square root of each side, or if it was x cubed, we could just take the cubed root of each side. So when we're dealing with something that has just a power, as long as that power is not a variable, it is not an exponential equation. So this one is not considered an exponential equation, and we can just solve by taking a root to match our power. Here, though, when we look, we see 2 to the x power is equal to 2 is equal to 2 squared. Well, we see that since our variable is in our power, that this is in fact an exponential equation. And when we're solving exponential equations, what we're looking to do first is if our bases match, which they do here, 2 and 2. So we're raising the same thing. So our base is being raised to a power, and it's the same base. Well, when you think about this, 2 raised to the x power is equal to 2 squared. Well, the only way that we can be equal when we have the same base being raised to a power is if our powers are equal. So once our bases and we identify our bases are equal to each other, we simply just set the power equal. Well, x in this case must be equal to 2, because if x was anything else, then it can't be equal to 2 squared. So our final answer, it should just make sense. Well, 2 squared does equal to 2 squared because x was equal to 2. So check. So once we see that we have the same base, we just simply go ahead and set our powers equal to each other and solve for it as if it was a basic equation, basic linear equation that we're solving for at that point. Because if our powers aren't equal, then of course then the base being raised to different powers will never be equal. So that's what we're looking for when we're trying to solve for these exponential equations. But you must understand that this one is not an exponential equation, even though we see a power, because our power must have a variable in it for it to be an exponential equation. All right, so we're just going to go through and solve a few different problems, and they're going to get a little bit harder as we go, but we're going to keep these more on the simpler side. All right, so for this problem, it says solve the given exponential equation. So when we're solving, the first thing we want to look at is our bases and say, okay, are our bases the same? And if they are, it makes it nice and easy for us. In this case, they're both 4 being raised to some power. So once we see that our bases are the same, we then take our 2 powers and we set them equal to each other. Because there's no way that this could be true unless the powers were equal, because 4 raised to the 5th power does not equal to anything else other than 4 raised to the 5th. So once we see that we have the same base, the only way that they could be equal to each other is if our powers are equal. So to solve for x, we simply set our powers equal. And now once we do this, it is a basic equation that we learned earlier in the year that we should know how to solve. So I'm going to move my x's to one side. So I'll subtract 2x from both sides and get negative x is equal to negative 8. And then since I haven't solved exactly for x's yet, I'll divide each side by negative 1, and x is then equal to 8. And if I plug it back into my problem, I get 4 to the 8th power is equal to 4 to the 2 times 8 minus 8. Well, 2 times 8 is 16. 16 minus 8 is 8. So you see I still get 4 to the 8 is equal to 4 to the 8 with guarantees that they are going to be the same because it's the same base being raised to the same power. All right, so once we're seeing it's an exponential equation, we're looking to identify our bases the same. And if they are, it makes it a lot easier for us. We simply just set the powers equal. Right, but sometimes they could be a little bit more challenging, and that there's a little bit more work that we have to do for this. So if I see this problem, 2 to the x minus 1 powers is equal to 2 to the x plus 1 raised to the second power. So here we see we actually have a rule that we learned already, and this is a power to a power. So a rule with power to a power is we would multiply. So before we start setting anything equal, we need to go ahead and simplify this as much as we can. So our rule is power to a power we multiply. So then all of this power would have to be multiplied by this 2. So we need to make sure that we are multiplying 2 times x plus 1, which then gives us 2x plus 2. Right, so now we have it's raised to the 2 to the 2x plus 2 power. So make sure that you are following our rules before you start setting things equal. Now that we have the same base, we can go ahead and set our powers equal to each other. So we get x minus 1 is equal to 2x plus 2, and now we're just going to go ahead and solve. So I'm going to subtract 2x from both sides, and I'll add 1 to both sides. So now I get negative x is equal to 3, but we're not done yet because we need to solve for the positive x. So I divide each side by negative 1, and then we get x is equal to negative 3, and that would be our final answer for this problem. All right, so sometimes there might be a little bit of work that we have to do beforehand by using some of our rules, whether it be a power to a power, whether it be multiplying. We might have to go ahead and simplify by using our law of exponent rules that we learned before we can go ahead and solve. All right, so for here I have 2 to the x times 2 to the 4th is equal to 2 to the 5x minus 4th. So before I go ahead and solve this one, I need to first combine these. In order for me to solve, I need to just have 2 to some power is equal to 2 to some power as well. Here I have multiple bases of 2, so before I can go ahead and start setting any powers equal, I need to combine these two into just one. And we have a rule for this. When we're multiplying with like bases, we can go ahead and add our powers. So this could be rewritten as 2 to the x plus 4 power because like bases, we can add our powers. We can't actually add x and 4 together as far as simplifying it any further, but we can rewrite it as 2 to the x plus 4 power by using our exponent rules. And this is then equal to 2 to the 5x minus 12. So now once we see that we have just one base written on each side, now we can go ahead and say, okay, they're the same. And since they're the same, I can go ahead and set my powers equal to each other and say x plus 4 is equal to 5x minus 12. So sometimes you will have to use some of our previously learned rules in order to solve. So we'll subtract 5x from both sides and subtract 4 from both sides. So now I get negative 4x is equal to negative 16. And the same thing, we need to divide each side then by negative 4 to get that as a positive x. So x is then equal to positive 4, and that will be our final answer. All right, so we went through, sorry, this should have been example 3. We went through a few different examples where one, the bases were flat out the same. There's nothing else that we need to do, just set our powers equal. And then we went through a couple examples where we're applying our laws of exponent rules to simplify to get it down to just one base on each side of our equation. So that way we can set those powers equal. And in this case, we were multiplying our like bases, so we added our powers. And in the other cases, we had that power to a power rule, so we had to multiply. So we still need to remember some of our previously learned rules with our exponent, with our laws of exponents to help us to solve some of these equations. All right, there's a couple more that I'm going to do with you, and both of these are now going to be where they're a little bit harder, where we're now going to start manipulating our bases in order for us to solve. All right, so the next problem we have 2 to the x power is equal to 16. So remember, this is an exponential equation. And when it's an exponential equation, we can't take the root of a number. And maybe you might be able to identify what this answer is right off the bat without needing to do anything. But when we see that we have two numbers that don't have the same base, what we do is we look at the smaller base and we say, okay, can we manipulate this at all? And for now, we're not going to. The smaller base is just going to remain that smaller base. So we take that larger number and we ask ourselves, can we rewrite it as a smaller base raised to a power? So can I rewrite 16 as 2 raised to some power? And yes, 2 to the fourth power is equal to 16. So instead of me writing it as 16, I can just rewrite this as 2 to the fourth power. So now I got 2 to the x is equal to 2 to the fourth power because these are equivalent. They're the same. I can substitute 2 to the fourth in anywhere I see 16 because they're equal to each other. And now by doing this, I see, oh, wait, now I have the same base. And once I have the same base, I know I can solve by just simply setting my powers equal to each other. So that means x is equal to 4. Right? So sometimes when it's not given to you with the same base, we might have to say, okay, can I rewrite the larger base as the smaller base raised to a power? So 16 can be rewritten as 2 to the fourth power. So I manipulate my equation by rewriting 16 as 2 to the fourth. And once I did that, I can see, oh, well, now I have the same base, so the powers must be equal to each other. All right, so there's one more that we're going to do for this. All right, so for this problem, which is the last one we're going to do in this video, we have 3 raised to the 4x power is equal to 27 raised to the x plus 1 power. So when I first look right away, I see my bases don't match. So when they don't match, I look at the larger number and say, can I rewrite 27 as 3 raised to some power? Well, 3 to the first power is 3. 3 squared is equal to 9. And 3 cubed is equal to 27. So yes, I can. I can rewrite 27 as 3 cubed. So where I see 27, I'm going to substitute it as 3 cubed. Now, I'm going to make sure I put this in as, whoops, this should be 4x, as parentheses, because now it is 3 to the third power is equal to 27, but it's still being raised to the x plus 1 power. So here I actually have a power to a power rule that I have to use. And we know power to a power means we multiply. So I need to distribute that 3 in. So this now becomes 3 to the 4x power is equal to 3. Well, 3 times x will give me 3x. And 3 times 1 will give me plus 3. So I need to make sure I'm distributing this in and using our rules properly. And now that I see this, well, now my bases are the same. So you see I was able to manipulate this right-hand side of the equation so that this way we do have an exponential equation with the same base. And now once we do that, we can set our powers equal to each other. So 4x is equal to 3x plus 3. And then to solve, I can just go ahead and subtract 3x from each side. And now I get that x is equal to 3. So something that looked like I couldn't solve in the beginning because they weren't like bases, as long as I learn how to manipulate or know how to manipulate my bases, I can look to see, can I continue this? Can I keep going? And we're always going to just take the larger number and see, can I rewrite it as a smaller number, as a smaller base raised to that power? And for any question we're getting right now, we will be able to. But when you learn this again next year, the year after, you're going to learn another method that sometimes we can't rewrite these bases to match. And when we can't, what method do we use for that? But for now, we're just going to go through, and you'll always be given problems that you can manipulate your base and rewrite them. And it's going to make sure that you're using your laws of exponents properly in order to solve. All right, that is it for this video.